Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the projections of the oblique plane which happens to be inclined to the reference plane's horizontal plane as well as the vertical plane. So now we have got the regular hexagon having h is equal to 30 millimeter, and the surface of this regular hexagon, it makes an angle of 45 degree with respect to the horizontal plane. Now since the surface of this regular hexagonal lamina, it makes an angle of 45 degree with respect to horizontal plane, therefore we are going to assume that to begin with this hexagonal lamina will be resting onto the ground or it will be parallel to the horizontal plane. And another information we have got that one of its sides, it is resting in the horizontal plane. So since one of the sides of the hexagonal lamina, it happens to lie onto the horizontal plane, so we have to assume that to begin with the hexagonal lamina happens to lie onto the horizontal plane. Therefore, first of all, the projections of the lamina in the top view, that is below the XY line, will have to be drawn as a starting point. And now we have to decide about the orientation of this particular hexagonal lamina, the way it will be located onto the horizontal plane. So if we have the orientation of the hexagonal lamina onto the ground in this orientation, then if we incline this hexagonal lamina either like this or in this orientation, what will happen? The hexagonal lamina will be resting onto the ground on one of its corners over here, either this corner or it will be resting on the ground onto this corner. So this is going to violate the requirements of this problem statement, because we know that this hexagonal lamina is having one of its sides in the horizontal plane. So we cannot locate hexagonal lamina into this orientation. So when we have the hexagonal lamina located onto the horizontal plane, that is in the top view projections, which will be drawn below the XY reference line in this orientation, then what's going to happen? Whenever we incline this hexagonal lamina either in this orientation or in this orientation, what's going to happen? It will be either resting on one of the edges of the hexagonal lamina onto the ground, or it will be resting on this edge of the hexagonal lamina onto the ground. So we can incline it this way or we can incline it this way. So now once the surface of the lamina, it is inclined with respect to horizontal plane at an angle of 45 degree, what's going to happen? We are going to have foreshortening of this edge, this edge, this edge and this edge. But this edge will be resting onto the ground, and this edge, even though it is lifted from the ground, but it is still parallel to the ground. So the apparent shape or the foreshortened shape of this hexagonal lamina will be visible to us into the top view projections. But the special characteristic of this apparent shape of the hexagonal lamina will be this, that is this edge, because it is resting onto the ground, it will be true length, and this edge which is lying above the horizontal plane but still it is parallel to the horizontal plane, it will also be the true length. And these four edges of the hexagonal lamina, they will be represented as foreshortened edges over there. Now we have been provided with the information that one of its sides which is lying in the horizontal plane, it means it is this edge we are now talking about. So this edge which happens to lie in the horizontal plane, it is further inclined at an angle of 60 degree with respect to the vertical plane. So with this information, we are required to draw the orthographic projections of this regular hexagonal lamina, right? So here we have the XY reference line. Then we have to draw, to begin with, the top view projections of this lamina onto the horizontal plane. And this true shape we will be obtaining into the top view projections of this particular hexagonal lamina. So here we have got the edge of this particular hexagonal lamina equal to 30 millimeter. So A, B, C, D, E and F. So these 6 points corresponding to this hexagonal shape, they have been marked in the top view projections, and we have been able to obtain the true shape of this hexagonal lamina because this hexagonal lamina is resting onto the ground over there. So now when we look at this particular hexagonal lamina from the front side, that is this side, then because it is resting onto the ground, so on the XY reference line, we are going to obtain the front view projections of this lamina in the form of an edge view. So we can check points B and A if they are projected onto the vertical plane. So B dash and A dash points, they will be located onto the XY reference line. Similarly, C and F points, they will be observed as C dash and F dash points onto the XY reference line. And finally, we have D and E points. And then once we are looking at this lamina from this direction, so D and E points, they will be projected onto the XY reference line in the form of D dash and E dash points over here. So here we have got 3 projections which we have been able to obtain corresponding to B dash A dash, C dash F dash and D dash E dash. So now we will be obtaining the length of this edge view in the front view. Now once we have been able to obtain the edge view of this lamina which is resting onto the ground, now we know that this lamina, it happens to be inclined with respect to the horizontal plane at an angle of 45 degree. So the surface of the lamina is making an angle of 45 degree with respect to horizontal plane. So this edge view which we had obtained previously, this has to be reoriented in such a way that we have to maintain these 3 distances into the inclined projection over here. So we can check these 3 points we have marked over here. So the distances between B dash A dash and C dash F dash, so this we will be marking alongside this particular orientation of the line inclined at an angle of 45 degrees. Similarly, the distance between C dash F dash and D dash E dash, so this distance will also be maintained into this reoriented or inclined edge view projections which are being obtained in the front view. So the new projections, they are B1 dash, A1 dash, C1 dash, F1 dash, D1 dash and E1 dash over here. Now we have been able to obtain the front view projections of this lamina whose surface is inclined at an angle of 45 degree with respect to horizontal plane. So now the corresponding top view projections we need to obtain. So in order to obtain the projections in the top view corresponding to this inclined lamina, so the horizontal projectors we need to draw through all the plan projection points which are available with us in the previous plan projection view, and vertical projector lines we need to draw from these 3 points over here which are going to represent 6 points of the hexagon, because couple of points they are being coincided or overlapped with each other at these 3 positions of this edge view. Now we are going to find the corresponding projections of this particular lamina in the top view. Now here we can see this is vertical projector through A1 dash, this is horizontal projector through A. So wherever these 2 projectors corresponding to point A they intersect, A1 point has been obtained in the top view. Now this is vertical projector line from the point B1 dash of the elevation. We bring it down till the position where it is going to meet with the horizontal projector drawn through the point B of the plan. So B1 point has been obtained. Similarly, this is the vertical projector line corresponding to the point C1 dash. So we'll bring this down till the position it is going to meet or intersect with the horizontal projector line which is emerging from the top view projection point C. So this gives us the location of the point C1. Similarly, vertical projector through D1 dash and horizontal projector through D. the intersection will give us the point D1 over here. Similarly, the vertical projector through E1 dash and the horizontal projector through E, wherever they intersect. So this intersection point provides us with the location of the point E1. And finally, this is vertical projector drawn through the point F1 dash. This is horizontal projector which has been drawn through the point F of the plan. So the intersection of both of these projectors, they provide us with the location of the point F1 over here. So the plan projection points corresponding to the corners of this particular hexagonal lamina, they have been obtained in the top view projections when the lamina happen to be inclined with respect to the horizontal plane at an angle of 45 degree. Now this is the apparent shape of the lamina, but the special characteristic about this apparent shape is edge A1 B1, it is still true length. Edge E1 D1, it is also true length. Why? Because E1 D1, even though it is lifted upwards, but still it is parallel to the horizontal plane. And edge A1 B1, it is contained by the horizontal plane. So the lamina is resting onto the ground, onto this particular edge A and B over here. So this edge will still be represented as a true length, whereas A1 F1, F1 E1, B1 C1 and C1 D1. So these four edges, they represent the apparent lengths corresponding to these four edges, because this lamina surface is inclined with respect to the horizontal plane. Now having obtained this apparent shape, now we know that the edge or the side of the hexagonal lamina which happens to lie in the horizontal plane, it is this one. We can check this inclined lamina, it is resting onto the ground, onto this edge which happens to be AB, A1 dash, B1 dash. So it is resting onto the ground or horizontal plane with reference to this particular edge. So this edge which is represented as a true length in the top view projection, so this edge happens to be further inclined with respect to vertical plane at an angle of 60 degree. Now we can check. We have drawn the orientation projection line corresponding to 60 degree inclination over here. Now this hexagonal apparent shape which we had obtained previously, this has to be shifted at an angle of 60 degree with respect to the vertical plane in such a way that onto this orientation line, the edge A1 B1 we should be able to locate. So A1 B1 edge, that is, it is this edge which is resting onto the ground. So this edge must lie onto this particular orientation. Now how do we transfer this figure onto this 60 degree inclined orientation? We have inscribed this hexagonal apparent shape into this rectangular figure over here. So what we are going to do? We are going to measure shorter length of the rectangle. We are going to measure the longer length of the rectangle. We can check the longer length of the rectangle we have placed over here alongside 60 degree, and over here A2 and B2 points, they will be located, and this is the shorter edge of the rectangle. Now we have to transfer this hexagonal shape using the rectilinear distances over here. How we can do it? The longer edge we have measured. Now we know that with respect to this corner, so this distance we have to mark. With respect to this corner of the rectangle, this distance we have to mark on this side. So the moment we mark this distance corresponding to point A, we mark this distance rectilinear corresponding to the point B from this corner. So we are able to locate A2 and B2 points onto this inclined projection line over here, or the inclined reference line over here. And we also know that A1 B1 was the true length. So therefore A2 B2 edge of this particular hexagonal lamina, it will also be representing the true length of this particular edge. Now having obtained A2 B2, now in the rectilinear way I know this distance. From this corner I should be measuring this distance. From this corner, once I measure this distance, I will be able to obtain C2 point over here. Similarly, from this corner, if you measure this distance, point D2 will be located. From this corner, if you measure this distance, E2 will be located. So from this, measure the distance E2. From this point, you measure this particular distance you will be able to locate point D2 over here. So D2 is located, E2 is located, and finally F point. From this corner you measure this distance. That is, from this corner you measure this distance over here. So point F2 has also been located into the plan projection view. So now you see, this is the plan projection view. So once we join all of these 6 points, now the plan projection of the oblique lamina, which is inclined with respect to HP and with respect to VP, has been obtained. Now the corresponding elevation projection needs to be obtained. So this will be possible when through these 6 points we are able to draw the vertical perpendicular projections, and from these 6 points we are able to draw the horizontal projector lines over here. So wherever the corresponding projection lines they are going to intersect, so we will be obtaining the projections of these 6 points of the hexagonal lamina in the front view. Now we can see from point A2, we have drawn a vertical projector line, extended this projector line in the upward direction till this projection line, it intersects with the horizontal projector line which has emerged from point A1 dash. So this is horizontal projector from A1 dash should intersect with the vertical projector from the point A2 over here. So this provides us with the location of point A2 dash. Similarly, the vertical projector through B2 point, it has been extended upwards, and the horizontal point through B1 dash point, it has been extended from left to right. So wherever the horizontal projector drawn through B1 dash, it intersects with the vertical projector drawn through the point B2, we have been able to obtain front view projection corresponding to the point B2, that is B2 dash. Similarly, from C2 dash, so the intersection point of the vertical projector through C2 over here and the horizontal projector which we have drawn through the point C1 dash. So this intersection provides us with the location of the point C2 dash. Similarly, the vertical projector through the point D2 and the horizontal projector drawn through the point D1 dash. So wherever these two projector lines they will intersect, we will be able to obtain the location of the point D2 in the front view, that is D2 dash point has been located over here, right? Then corresponding to the point E2, again we have drawn a vertical projector line, extend it upwards till it intersects with the horizontal projector line drawn through the point E1 dash. So this intersection of the vertical projector through E2 and horizontal projector through E1 dash. So this provides us with the location of the point E2 dash in the front view. And finally, the intersection of the vertical projector drawn through the point F2 and the horizontal projector line which has been drawn through the point F1 dash. So it provides us with the final intersection point, that is F2 point in the front view, F2 dash. So the 6 points of the lamina in the front view they have been identified. Now we can join all of these 6 points. So this way we have been able to obtain front view projections and the top view projections of an oblique lamina whose surface is inclined with respect to horizontal plane at an angle of 45 degree and the edge on which it is resting onto the ground, this is the edge AB, the edge onto which it is resting onto the ground, this edge true length, it is further inclined with respect to vertical plane at an angle of 60 degree. So this is all for today. So I hope that through this discussion you would have understood about the procedure to evaluate the orthographic front view projections and top view projections of an oblique regular hexagonal lamina which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. So we will be continuing with further discussion regarding few more illustrative cases related to the orthographic projections of the planes in the coming lectures as well. So thank you very much. Thanks a lot.